All right, so we're live with the recording. Yes, so as I was saying, we did if statements last week, and we took a look at the different if statements, just being like the if statement itself, where you do a decision or you do nothing, the if else, where you kind of have a binary choice based upon a condition being fulfilled, something is done. Or if a condition is not fulfilled, something else is done. Or if you have the if, else if, else if, else structure, where you can have multiple conditions. We took a look at some examples. We did enough some flowchart examples along with it. So we had the if structure just by itself without an else, where if the structure is true, you do an instruction, otherwise the instruction is not done. So we see here, once this structure allows us to go on the true branch, we do a task, otherwise we don't do a task. Then we have a scenario where, of course, we have it's a binary decision. You have to do one or the other. Okay. And then in this case, like the if else if it is that you have a decision being made, then you do a task. Otherwise, you could get further criteria, right? You can have a choice you need if it's false or if it's true. Okay, so this last false here, that else condition, where if none of the other criteria could be met, then this is going to be done right. So then we took a look at an example in terms of a problem. We had a situation where we wanted to calculate the cost of water usage. Okay, we knew that some people interpreted it a little different from others, and but at the same time, we wanted to focus on two things, right? We wanted to focus on using the if structure, and we wanted to focus on ensuring that our criteria is well represented so that we can, make our choice along the if structure. Then we spoke about flowcharts. We took a look at the different parts of a flowchart, the flow lines, the on-page connectors, off-page connectors. We took a look at the decision box, which is how we represent the if structure in programming, in flowchart, sorry. The process box, where instructions will go, and declarations will go, and assignments will go. Input-output box to take values from the user, to give values to the user, and everything is represented in a start-stop box. I want to add one thing here, which might be useful, but I don't know if we'll cover it in this course, but I'm just going to highlight it as a option to be added. Okay, so we also have a function or a process box. So this is when you call a user-defined a function or a process box. And this is where you have a user-defined function or process, and you want to call it, and this function or process box is actually going to be linked to another flowchart, a smaller flowchart that will represent the activities associated with that function. As I said, I don't think that we'll get to that point before the end of the term, but we'll see how it works out for us, right? But I want to just highlight that that is also a flowchart symbol that you might see for when you're reading on your own. All right, we spoke about functions just as a pre-existing bunch of codes, the built-in functions that might exist across all programming languages, and how you could use it when it comes to writing your own programs, because you can make assumptions that these functions exist, even in pseudocode. Okay, things like square root and absolute values of a value of a number, they are so often used. Things like random, you could just call the function for a random. So if we say, for example, in a flowchart, we want to call a random number, then we will, we want to cite a random number, then we will call the random function. Okay, and then we have sign, okay, which could tell us whether a number is positive or negative. We have some string functions here that will return some parts of a string, right? Basically, break up a string or tokenize a string, as it might be called. And again, that's something that we will see in C at some point. I don't think that we get to there in C here, but these string functions, there's something similar to this inside of the C programming language. And then you have regular conversion functions to change one data type to another, or we have some functions that are statistical, used in terms of summing up values in a list, okay, or finding the average of a list of values. Like if you have an array, or if you just have a string of values to enter, you would be able to put them inside there. And then of course you have utility functions. So if it is, that you writing some pseudocode, and you think that pseudocode is going to pseudocode is going to be translated into a language like Java, where there are error handlers and stuff like that, then you could always call the error function, and you could call the error function, and you can have it when you are doing your Java programming language, if you know how to do it, put in the error handling there if you expect an error in that event. Okay, but remember that the goal of our pseudocode is to have a piece of some code, or to have some a program, the structure of a program, the logic behind a program. Okay, and it's good enough for anybody to read. That person doesn't have to know a specific programming language. That person just has to be able to do logical thinking, etc. Any questions so far? All right, this is just a recap of last week. Nope.
No, sir.
Good. All right. So this is today, and today we're going to talk about looping. Okay. So we want to talk about looping today. And I'm going to ask a question here that anybody could answer. Hope I don't have to call a name for somebody to answer. But what is looping? What is looping? Just having a conversation. Anybody?
Hi.
Mm-hmm.
Looping is when you make the program perform a task over and over until you get until it meets a specific criteria.
Yes. Thank you very much, dear. Okay. So looping is repeating instructions until a particular criteria is met. And that section that says until a particular criteria is met could mean one of two things really. It could mean that the criteria for looping was set beforehand, where we gave it boundaries, or it could mean that that criteria for looping could be any value, and we don't know upon how much times something has to loop before we meet that value. So the first instance in terms of looping is called bounded iteration. So we have bounded iteration. And for bounded iteration, we typically, as I said before, know our criteria for starting and stopping the loop. So we know our criteria for starting and stopping the loop. Okay? And in terms of us being able to start and stop the loop, we use a structure in programming. We use a structure called a for loop. And so how do we arrange this for loop? We basically say for a given variable, right, is equal to a start value to a stop value and we provide some kind of increment value as well. So what's in green is kind of like, values that we have. What's in this here, of course, is your variable that will act as a counter, that will move your start value towards your stop value, looping by whatever your increment value is on every iteration. Okay? So this one variable here starts off here and it moves to here. An example of this. All right? And if anybody have a question, you could put up your hand in the class, and if somebody see that the hand is up, because I'm on a single screen here today, if you see that one hand is up, then, and somebody not seeing, you could always say, hey, sir, my hand is up or something. So, but I think I normally hear when the hand is up chime. Okay? So let's take an example. So for example, if it is that we wanted to simply print all values between 1 and 100, we can use a for loop for this because we've been given the start value and we've been given the stop value. And we want to say, okay, what is the instruction that we want to put or we want to repeat over and over from when we're at the number 1 up to the number 100. We want to print whatever is the current value that we're at. So we need a variable. So we can have a variable I, which is an integer. So we could say int I up here, declare I. And we could say for I starts at 1 to 100, step 1. And this step 1 tells me every time I reach the end 4, we're not over 100, continue looping. So I could see inside of here, print I. We could see inside of here, print I. So what are we saying here? We're saying for I is equal to 1 to 100, print I, end 4. So what is my output going to be for this particular question? So my output will look something like this: 1, 2, 3, 4, 5, ... up to 99, 100. And that is because every time that we run through, I started off at 1. We say, okay, it's at 1. Is it at 100 yet? No. So print I. When we hit the end 4, that's when we do the step 1. Okay, that's when our increment gets executed. And we'll do the step 1, so then I goes up to 2. So we say, is 2 equal to 100? No, it's not. 3 equal to step 1. Is 3 equal to 100? No, it's not. Print 3. Carry by 1. Is 4 equal to 100? No, it's not. And 1. 5 equal to 100. We do that until it reaches 99 is equal to 100. Is 99 equal to 100? No, it's not. Print 99. Sorry, is 99 bigger than 100, I should say. Right? No, it's not. Print I, add 1. It's now at 100. Is 100 bigger than 100? No, it's not. Print 100. Carry it to 101. Is 101 bigger than 100? Yes, I'll stop the boat. Right? We get in that loop. Another quick algorithm, and then I'm going to call a random name and ask that person to tell me what the possible output for this will be. Okay? So I'm doing 2. So this is the first one. I'm going to put 4j is equal to 1 to 35. Step 6. Print j and 4. So let me ask somebody from the list. I'm seeing a Jordan Raheem Chapman. Can you talk?
Good afternoon, Sue.
Hi. So I'm asking you, just for the general knowledge, what is my output going to look like here? Okay. No problem if we don't quite get it right at this point, because we're here to learn.
I probably won't.
All right. So that's all I'm asking. So what is the value of I to start off at? The value of I to start off at is
1.
I don't start by misleading you. I apologize. The value of j to start off, because we dealing with this one. So the value of j to start off is 1. So the first output is going to be 1. So we print that j, and then when we hit the end 4, what do? We say step 6. Step 6 is the same as saying take 1 and add 6 to it. So what is the next value that's going to print out?
Would it be 2?
No, this is the second time we're going around. But what step 6 really means is add 6 to G. That's
So
what we're
that
trying
would
to
be
say
7.
here. It would be 7. So the second step is going to be 7. And then when we go down to this N4 here, we go up here and we say, is 7 more than 35? No, it's not. So we could continue on in this loop, right? And that's why we print out the 7. And then when we hit the N4, we add 6 to 7. So the next one would be
13.
13. And again, we do our check. Is 13 less than 35? Yes, it is. So we continue the loop, right? 13 is not more than 35. We continue the loop. Okay, that's why we printed out the 13. Then you add 6 to 13, which would be
19.
Right, so we go 19. Next 6 would carry us to 25.
Oh, shucks, I didn't hear. Sorry.
That's all right. 6 will carry us to 25. And then we'll go to 31. Right? But then when we are 31, okay, so the last thing we printed out was 31. When we hit this N4, what happens to G? We add 6 to G. So now the value of of j is going to be what? 31
37.
plus 6 is 37. But what is our criteria for stopping?
1 to 35.
1 to 35. So we cannot go past 35 because it's saying 35 should be the maximum value that would allow us to get into this loop. Okay, so we don't print out 37. So the output of this algorithm, thank you so very much, Jordan.
No problem.
Okay, I'm saying your name correct, right?
It's actually Jordan.
I thought so, yeah. But, I apologize, Jordan.
It's
All right.
fine.
So, so we have the output here, and it allowed us to print out according to the rules. We can't print out anything when j is larger than 35. So when we jump past 35, right? Because 31 was less than 35, but 37 is larger. So we're going to try one more. Okay, I'm going to call one more person. One more person. So we have one more here, and we say for what? For x is equal to, I'm going to say n is equal to 3. Y is equal to 70, and p is equal to 4. Okay, so I'm going to say for x is equal to n to y, step p. Okay, 70 kind of large. Let me not use 70. Let me use 29. Okay, 29. So n is equal to 3, y is equal to 29, and p is equal to 4. And inside here, I'm going to say print x plus n. Now this one starts to get tricky. It starts to look like maths. Okay, start to look like maths. I'm going to ask for a volunteer for this one. I'm not putting anybody on the spot. First hand up, we'll walk through it. Don't all rush. Okay, so Porter. Okay, Porter is our brave brave contestant who's going at this solution with me.
So you hear me?
So yes, Porter, I'm hearing you.
All right.
So where do we start? Let's just deconstruct this a little bit. We have our variables. Where do we start? X is initially starting off at what value? Porter.
3.
3. We stopping at what value? What value should we
stop.
not pass?
29.
Stopping at 29. Every time we go around, how much does the value of x go up by?
4.
Right, so add 4 to x. And so we go in, we will do this statement inside here every time. So the first time that we loop, what is the value that should be printed out? Because if it is, and we could do a little trace table, we have the value of x, we have the value of y, we have the value of p, we have the value of x, y, p, we have the value of n, and we have the value of x plus n. And so we could do this, and then we could also show what our output is going to be like. And this should make it relatively easy for us to follow along. So the starting value we established, Porter established that the starting value of x is 3, because the value of n was 3. The starting value of y is 29, and the value of p is 4. So, Porter, what is my first output?
I think 6.
6 is correct because the value of x plus n is 6. So my output, the first thing that is output is 6. So where do I go from here?
Well, it's saying add 4 to x. So it'd probably be 10 for your next output.
Right. So what is the new value of x? No, let's not jump. What's the new value of x?
Okay. All right. Okay, the new value of x would be 7.
7. So x moved up to 7 when we hit the N4 because that's when we do this step. Okay? When we hit the N4, so we have 7 here as the new value of x. And so what is the next output? Well, it's going to be x plus n, which Porter established to be 7 plus 3, which is 10. So the output here is 6, then 10. Then what's the next output? What's the next value of x, Porter?
That would be 14.
14.
Oh shucks, sorry, no. I added 4 to 10, but I should have added it to 7.
To 7 because that's
yeah,
the
11.
x is our counter. So this is why I'm doing the trace table so we could keep track of the values as they change. So he's correct now. X is 11 because we added 4. We always adding 4. We always adding p to x. So the next value is 11. So then what is my next output value? 11 plus
4.
11 plus 3 is
14.
14. So that's the next output. 14. But then we go back to x, and we know that we have to add 4 to x. So the next value that we have is x plus p. Right? So remember, every time we finish print, we add p to x. So we carry this up to 15. And of course, now we have 15 plus 3 printing out, which would be 80. Am I correct there? X plus n, 15 plus 3?
Yeah.
18. Then we add 4. So the next value that x will have is
19.
19 because that's the step P. And then we print out because 19 is still less than or not equal to 29. So 19 plus 3 is
22.
22. So the next value printed out is going to be 22. And then we hit the N4. So that means that we add the value of x is going to be
23.
23. So the next value that will be printed out will be 23 plus 3, which will be
26.
26. So that's my next output value. And then we're moving up towards the end. So let's not stop. 23 plus 4 is
27.
27. 27, the value that we're printing out is x plus n. So 27 plus 3 is
30.
And then next thing that we have to do is add 4 to 27, which is going to be 31. But now look at this here. is the value of x less than or equal to the value of y?
No, you pass it, no.
We passed it, so this was our last output. We cannot go into the printer, towards the printer. So we end the for loop and continue execution. Are you all with me?
Yes,
This was
sir.
a
Yeah.
little trick. This one was a little trickier than the previous ones, yeah? I know that you all like to see teachers like to show, 2 plus 2 and then ask you to do some hard maths after that. But it's not that difficult. We just have to keep track, and I hope that keeping track, we kept track because we used the trace table. So because the thing is, it's very possible for Cape to give you a question. Say, all right, algorithm, show us the output for this particular algorithm. And this algorithm here would probably be with about 5 or 6 marks. Okay. Everybody, does anybody not understand how I achieved this output? Well, let me ask the other way. Are you all comfortable with what we do here so far?
Yes, sir.
All right. I got one yes. So that Jada is speaking for everybody.
Yes, sir.
Yes,
All
sir.
right. I
Yes,
got some people who, yeah, good. I got seconded, thirded, fourth. So we got to go with this for loop here. So let's keep this in mind, because now I want to go and speak about the other type of iteration, which is unbounded iteration. Okay? And I'm gonna stay along the track of working with numbers just for now, with the unbounded iteration. So we just did bounded iteration. Let's have a little discussion about unbounded iteration. What is unbounded iteration? Unbounded iteration, if bounded iteration is when the criteria for starting and stopping the loop is known, then unbounded iteration is when we do not know, right? When the criteria to keep looping will not be satisfied, right? Or will no longer be satisfied. Okay, so when we don't know when the criteria for looping is going to stop. Everybody fine with this? You all understand this? Okay, it could be now, it could be later, and these are things that we do in real life. Okay, we do for loops. Your teacher gives you answer. When do you stop answering? When 1, 2, 3, 4, 5, 6, 7 questions are answered. If it is that your teacher now says, okay, there are there are practice questions, or watch some YouTube videos on a particular topic, and they didn't tell you how much videos to watch. One person could decide, okay, after 2 videos, I stop it. Another person could say, nah, I really want to know about this topic. After 12 videos, they stop. Another person could decide, nah, I'm not watching any videos at all. Because what the teacher said was open. The teacher just said, watch some videos, right, about the topic until you feel like you understand it. So that last person could say, nah, I feel I understand it right now. Okay, I'm not talking about best teaching practice. I'm just talking about the instruction part of it. Right? The teacher should have sent a video, at least one video. But let's not debate that. we're debating the fact that this person needs to watch videos until they feel like they need to stop watching videos. All right? Hold 1 second, please. Yes. So we don't know when the criteria to keep looping will no longer be satisfied or will not be satisfied. Okay, and I feel like I prefer to put the words no longer there than not be. So let me change that. Will no longer be satisfied. And we have two types of unbounded iteration. And they're very, very similar. They are the do while loop and this loop executes instructions one or more times. So the loop can do it once and then we'll check to see if you want to stop. So that's kind of like if the teacher said, watch this video and then watch more videos on the topic if you don't understand. What do you have to do? What are you obligated to do? You're obligated to watch that one video. And if it is that you don't understand after that one video, then you're free to find as many other videos that you could until you understand what you have to do. And then we have the while loop. The while loop executes instructions zero or more times. Okay, so we execute instructions zero or more times. And what do we mean by that? We mean that the loop doesn't have to loop any instructions at all. That is like when the teacher says, okay, if you don't understand, watch some videos until you do understand. What is the criteria there? The criteria there is not understanding. So if it is that you understand, then you don't have to watch any videos at all. If it is that you understood, let's say for instance, right, Real decided to watch 2 videos, and after the second video, he have a aha moment. Real says, hey, yeah, I could stop watching videos now. I know all about this. And then let's say we have Clement, and Clement decide, no, Clement watched 7 videos, and Clement still feel I need to know more about this before I could say I understand. Let me watch one more video. All right. So Clement click on that 8th video, and then after that 8th video, Clement say, yes, that explanation was exactly what I needed. Clement could stop watching videos at that point. Okay, that is the difference between the while and the do while in kind of like a real world scenario. But we're going to take a look at some examples with numbers and the while and the do while. And the thing with the while and the do while, I mean, when you start a program, there are some situations where you're going to see that while and the do while. You're going to find out where you could use it, etc. They're not entirely interchangeable. Okay, you could use a while where a do while would have worked, but you can't really use a do while where a while needs to work. Understood? So there's a difference between them. Understood?
Yes, sir. Yes.
Yes, sir.
Oh, all right, good. So we are going to take a look at the while loop example first using some numbers. We're going to look at the while loop example first using some numbers. And then we'll take a look at the do while example. So let's say, for instance, we have an example here where we say int y is equal to 10. We can say do, well, let me not give a value to y. We could say int y, and we could say print, enter a number. And I say input y, so I take a value into y, and I say while y is equal to 100, or y mod 7 is equal, is unequal to 0, print y, end y. So what do we, sorry, not end y. I was setting ourselves up for trouble. Input y, and y. So we must have this value here called a sentinel value that allows us to eventually exit our loop. That mistake that I made there by not taking in a value for y after I checked and was inside the loop would have given me, in the case that the criteria for this was met, it would have made that loop infinitely. Okay, and that's a programming error. So, Mr. Valdez, you was giving the children some bad code. So let's talk this through. Anaya, are you there?
Yeah, here.
All right. Could we get a number for y?
Any number?
Any number.
5.
5. Okay. 5. Anaya, is 5 equal to 100?
Yeah.
All right. So that's this is true, right? Or is 5 actually I don't want unequal here. I'll change that, sorry. 5, while 5 is less than or equal to 100, I should say. So less than or equal to 100, not unequal. That give me a very slim. But is 5 less than or equal to 100? Yes. Is 5 mod 7 unequal to 0, Anaya?
Yes.
Yes.
No.
So we get two
Wait.
truths.
Yeah.
Huh?
Let's not
Right?
get mixed up. Yeah.
Right. So 5 mod 7, the answer to that is 5. Because if you divide 5 by 7, you get 0 remainder 5. Okay? So now we have a situation where we have true or true. And true or true will give us what?
True.
True or true will give us true. So we can go into this loop. So our output here, according to what we put, will print out the number 5. But then, Anaya, it asks us to enter another number into y. So what number are we putting into y? Now,
It would be the
you could
variable could
enter any
change
number.
halfway through.
I'm asking for a new variable, so yes, the variable will change.
Okay. Well,
That's
6.
6. So is 6 less than 100? Is 6 less than or equal to 100?
True.
True. Is 6 mod 7 unequal to 0?
True.
True. So what happens here? It will print out the value of
6.
6. Right. And what will happen after we print out the value of 6 is that it's going to ask for another number. So let's say, for instance, we put in the number 70. Let's say, for instance, we put in the number 70. We now have our while loop coming back around. We see is 70 less than or equal to 100? Is it less than or equal to 100? That's true. Is 70 mod 7 equal to 0? If I divide 70 by 7, what remainder am I going to get?
0.
0. So this is false. But we have an OR. So true or false gives us a value of
True.
true. So we print out 70. So let's assume that the next number that I entered is 350. Now let's take a look at our while loop. Is 350 less than or equal to 100?
No, sir.
No,
False.
so we end up with a false here. If I divide 350 by 7, do I get a remainder?
Yes, sir.
No.
No.
Okay.
No.
So 7 by 50 is 350. I believe. Right? Yeah. So we end up with false false. And in this instance, what does that tell us? It tells us that we cannot go into while. So we have to stop there. That's where we stop. That end while, we jump to the end while and continue on programming after this while loop. So that's example 1. Okay? We find here with example 1. Anybody
Yes, sir. Yeah.
have questions? No? Yes, we good.
So
Mm-hmm.
I'm not sure, sir, about the purpose of the second input. Why?
The purpose of the second input Y is to prevent us from never having an infinite loop. Let's take a look at it. Let's remove it and see what happens, okay? So let's say, for instance, I'm going to take this input Y here, and I'm going to just park it over here for a little bit, okay? So we have this loop here. And let's say, for instance, was it Clement who asked the question?
Porter.
Porter. Okay. All right. Porter, give me a value for Y that is less than 100.
35.
Okay. So let's take 35. Yeah. We have 35. Is 35 less than or equal to 100? That's true. Is 35 mod 7 and equal to 0? That's false. True or false would allow us to go into the loop. So what happens as our output in the second instance? We print Y, we print 35, and then we end while we come back up to the top here. But the value of Y is still 35. So we still with this true or false here. So we are 35. We print Y, that was the Y printed. We end while. We come here, it's still 35. So we print while, we end while. We still at 35. We print Y just now, we end while. We have no way to change the value of Y so that it allows us to come out of the loop. You understand what's going on here?
Yeah, following you.
So the purpose of this input Y here is really, really important. This input Y is going to allow us to change that value halfway, as you know, was asked earlier, so that eventually we can come up with a means of having false or false here that will allow us to break out of this while loop. Understood? Yes? No?
Yes, sir, yeah.
Right. So let's check this one last time. Let's say, for instance, the value that I enter into y in my initial is 700. 700 is not less than or equal to 100, so this is false. 700, so we're looking at the output here for 700. Okay, the 700 for y mod 7 isn't equal to 0, that is false. So we never get a chance to actually do it. So the output here is we have 0 output. So the number for the output in this one was 0. The number for the output without the sentinel value was infinite, and the output in the first instance was 3 until we met that value. I think it was 350 was our breaking point value. Okay, so 350 will not print because that's what our code says to do. It only prints if the value is valid. We need the sentinel value to prevent our loop from going on and on and on forever. And we for the last one, we could start off and look, the loop went in 0 or more times, which is, according to our definition, what the while loop is. Correct?
Right, sir.
All right. How you all feeling? We going well?
Yes, sir. Yes, sir. Good.
All
Yeah,
right.
we
So,
going well.
all right. Good, good, good. So nobody brain on fire or anything, so right?
Not
No,
yet, sir.
sir.
It was on fire for a little bit, but cool back down.
Cool, man. That's good. That's good. The auto systems kick off, and you know we're not in trouble. So the what are we or more times? So the do while loop is kind of like a inverse of the while loop, right? In a manner of thinking. Don't think about it as absolutes, right? I'm tempted to say only a Sith thinks in absolute, but I don't know if anybody will get it and if people like Star Wars and all of that. So I'm not going to say it, even though I just said it. All right. So we have print y, input y, and we're going to check. So we have int y, so we'll have to change the order a little bit for the do while loop to make things a little more sequentially appropriate. So we have int y, we have do, print, enter a number, we have input y, okay, so we have do, print, enter a number, input y, and then we will say print y. All right. Then we will see print y, and we say while y is less than or equal to 100, or y is y mod 7 is equal to 0. Now we have no end do while at the back here. Okay, this is just this one is kind of open, right? Because again, the do is up here and saying what instructions to do while we have this. So let's take a look at some numbers. I want some different people to talk to me. So Andre,
Yes, sir.
All right, Andre, you're with me here. Let's follow the logic here. We have int y. We say enter a number. So let's input. Give me a number, Andre.
52.
50. So we have the number 50. And what is our output going to be at this point? Output is going to be 50 because, and then we check, right?
Yes.
Is 50 mod 7 and equal to 0? If you divide 50 by 7, would you get a remainder?
Yes.
So then this statement is false because 50 is
Yeah.
not divisible by 7. But because we have true or false, we know that we can continue looping. Not so?
Mm-hmm. Yeah.
Right. So we'll get enter a number again, and Andre, give me a new number.
19.
19. Is 19 less than or equal to 100?
Yes.
Sorry, we print 19. And then we check to see if 19 less than or equal to 100? Yes. Is 19 mod 7 going to leave a remainder? Right?
Yes.
Yes, it is. So this part is false.
Excuse me, sir.
Right? Mm-hmm.
Excuse me. So
Yeah.
you said that 50, 50 falls under the falls under y is less than or equal to 100, but doesn't fall under y modulus 7 not equal to 0. That's what you said.
Yeah, because 50 divided by 7 is 7 remainder 1. So the answer for this is going to be 1. 1 is equal to 0. Oh, sorry, this is true.
Yeah.
My bad. True. The same is true for 19.
Yeah, say that.
Right? All right. My mistake. My brain old, a little young, and a little fresh. And that's why I'm taking my correction. Okay? So thank you for the correction. All right, so the same was true for 19. So that's why I said earlier, I know I'm human, I can make mistakes. And this is why it's better to write down everything when you're doing these things. So we're going for one more number, Andre.
232.
You're coming in broken up. Can you repeat?
100. Yeah. 232.
232. Andre's gonna have me doing maths here today. So we print out 232, and we know that at a glance it's easy for us to say 232 is not less than or equal to 100. So this is false. All right. If we divide 232 by 7, all right. So we have 232, and we have 7. 7 into 23 is 3. This is 21. 23 minus 21 is 2, and carry down the 2, so this is 2. 7 into 22 is 3. 3 by 7 is 21. All right, so we have a remainder of 1. Okay, so 1 isn't equal to 0. This is false. So 232 will still carry us along the loop. Okay, and then we have our trusty number of 350, which I know will give us a false and a false. Correct? Okay, so the thing is though, we have to print out that 350 before we can get to this while loop, because that's it. We put in 350, we print while, we see that we get false, and there is where we will stop. That makes sense? Because if I were to take, we starting over, if I were to take the output, and I said that we going through this the first time, we initialize y, We say enter a number, we put 700 here. What comes directly after this? Print Y. 700 will print out. And then we can get false and know not to continue. Correct?
Yes,
I
sir.
think go on silent, yeah. So you see in this case, that the instructions held within the do-while loop are executed. The instructions held within the do-while loop are executed, what you call it, at least once before we can choose whether to stop or continue. So in this case, the minimum amount of times that we'll execute is one time. We had one time for output here, but we had 4 outputs coming out of here. You all fine with the difference between the while loop and the do while loop? We have the while loop, we have the do while loop. Yes, sir. All right. Good, good, good. Any questions before I move forward? No questions before I move forward? Okay, cool. So, with that being said, I am going to give us a couple. Is that okay with you all? Because I want to give you all two problems, and I want to give you all about 20 minutes to do the 2 problems. And then we will take about 15 minutes to probably solve the 2 problems. So is it okay with you all to stop at about 20 past 7 tonight?
That's no sin, sir.
All
Yeah,
right,
that's
Yeah,
fine.
thank
that's
you. That's fine. All right. Okay. So, right. So I'm going to put up some problems on the screen, and let us see what is the problems, what is the issue inside of here. All right. I'll put up this one first. We could start here. Okay, so the problem is find the average score for 5 people. Find the average score for 5 people. We have a set of instructions, and we want to correct the following set of instructions. So let's start with this one. I'm going to put one more up on the screen, or maybe 2 more up on the screen. Okay. I'm going to type it out. Allow a user to enter a number following is number entered. Excuse 1 second. All right, so attempt these two, please. Sorry about that. All right, so example 6, I'm going to put asterisks instead of dashes. 1, 2, 3, 6. All right. Example 9. 1, 2, 3, 4, 5, 6. Actually, I'm going to give you all a little challenge. 3, 6. Okay, so let's attempt these two questions, please.
Say, I just quick question, right? Do we have to use all of these symbols in our code, or could we just use like one example, like an asterisk or something?
No, you look at the instances where the asterisk comes out, and look at the instances where the plus signs come out. There's a reason
Oh,
the
okay.
code has to incorporate both of them.
Makes sense. Thank you.
All right. So we're going to take a look at these two questions. And let me ask Musa. Did I say your name correct?
Yeah, yes, you did.
All right. Could you tell me for the first question, what is missing from finding the average score for 5 people?
A line that does the calculations to find average.
Okay, so could you give me that line and tell me where it goes?
Yeah, after the while loop ends, there should be a part that says average equals total divided by 5, and then there should be like
Okay,
a print average.
okay, print average. Okay. Oh, yeah. All right, so we have this. Anything else is missing, Musa?
So counter should be
On
equal
the
to 0.
Yeah. All right, so counter should be equal to 0 because it says while counter is less than 5. So to get 5 entries, we would have to have 0, 1, 2, 3, 4, which will give us 5 entries. Alternatively, we could have also gone with putting while counters less than or equal to 5. Okay? So either one of those two changes would work. Any other issues? Somebody has messaged. Set?
Yeah, so when you have to put an X underscore below counter.
We no. No, because each time it will go around and do this block of code. So you enter the score. No, you when it comes back around, it will enter the score for the second person. And we'll run through it, but we're missing one more thing.
So I have a question. Do we have to initialize total?
We do. That's what we are.
Okay, sir.
Like, what value should we initialize total to?
0.
Total needs to be initialized to 0. Because if we don't say what value total is, what are we adding score to? Okay? So if total was never given an initial value, then the value inside of total is unknown from the first time that we ever try to add total to score. So let's see if we can draw a little trace table. Quickly, I'll just put T for total, I'll put C for counter, I'll put S for score. Okay? And I'll put A for average. And our values for total started off at 0. Counter started off at 1. We say while counter is less than or equal to 5. So is 1 less than or equal to 5? Yes, it is. We enter the score. Let's say the score for the first person is 8. We say total is equal to total plus score. So the new value of total is 0 plus 8 will now be 8. So when we have something like this, which is called an accumulation, okay, this is the name for this is an accumulation. What we do is that we do what's on the right-hand side first and then do the assignment to the left-hand side. So even though total is part of the accumulation, we using the old value of total, adding it to score, and then making that the new value of total. So that's why we have 0 plus 8 is now 8. And counter is equal to counter plus 1. So counter goes up by 1. So counter is now 2. Counter is now 2. So when we go end while, right, is counter less than or equal to 5? 2 is less than or equal to 5. So we enter the score. We could enter 7. We could say total is equal to total plus score. So 8 plus 7 is 15. We say counter is equal to counter plus 1. Counter is now 3. We go to the end while we come back up. Is 3 less than or equal to 5? Yes, it is. So we enter a new score, 9. Total is equal to total plus score. So total is now equal to 24. Counter is equal to counter plus 1. So counter is now equal to 4. All right, we go down. 4 is less than or equal to 5. So we enter the score. We enter a score of 4. 24 plus 4 is 28. Total is equal, right, sorry. Yeah, that's what we did just now. Counter is equal to counter plus 1, so counter is 5. So we check, is counter less than or equal to 5? Counter is not less than 5, but it's equal to 5. So we have to go in and we enter the score. Okay, so we have 7. And we say total is equal to total plus score. So 28 plus 7 is 35. Counter is equal to counter plus 1. This is now 6. We end, we come up. Is counter less than or equal to 5? It's neither less than nor is it equal to 5. So now we jump over the control of the loop because we can't enter it. And we say average is equal to total divided by 5. So the average is going to be 7. So our output is going to be 7. Everybody with me?
Yes, sir.
Okay. And the second question, any volunteers to share the second question? Oh, people tell me they're done. What's going on here?
So I could go.
Yes, yes.
So I have print enter number.
Okay, so print, enter number. Uh-huh.
And then I have input n.
Input n.
Now, if n modulus 2 is not equal to 0,
n mod 2 is unequal to 0.
is not equal to 0, then while n is not 0,
While n is unequal to 0,
print the plus sign.
print plus sign. Okay.
Then n is equal to n minus 1.
N minus 1. Okay.
Else,
So n while, else,
yeah, n while. Else, while n is not equal to 0, print star.
while n is not equal to 0. Right.
Yes,
Okay.
print star.
Print star.
N is equal to n
What
minus 1.
else?
And while.
N is equal to n minus 1. And while, and
That's
end
it.
if. Right,
Yes, and
end the
if.
if. Okay, so this will work. You did it a bit opposite to how I would have done it. I would have put the loop around and put the if inside rather than write two loops, but this will work. Okay, so this is one way, and I will just put my solution next to it, which is how I would have written it, which is about the same. So I would have gone print enter number. I actually would have used the for loop as well. So I would have said input n, and I would say for right, for I is equal to 1 to n, step 1. And then I would have said if n mod 2 is unequal to 0, okay, if n mod 2 is unequal to 0, print plus sign. Else, print an asterisk. And if and 4. So it's
Say, stick there for me. Sir?
He's frozen for me also.
but you can't use for loops to do unbounded iterations. Okay? Or you could in a way. I'm kind of lying, but it's not going to be the best of solutions. All right? So try. Yes.
So you could like repeat what you just had said because you kind of like cut off a little bit.
Okay,
Right.
about the for loops and the while loops.
Yes, sir. Well,
Right.
I
I
don't
said
know.
all right. I said that you could use a while loop to do a bounded iteration. So a while loop could technically do bounded and unbounded iteration, but a for loop can only do bounded iteration. To get a for loop to do unbounded iteration, the programming gods will not be happy. Okay? So I think that we did well for today. It's actually just about 8:07. So I think that this is a good place to stop. Before I stop completely, I'm going to ask, does anyone have any questions or comments or identified any errors in what we've done here. Yes, Anaya?
I don't really have any questions, but I have a comment. You know what was messing me up? Like you see on the example, it have 6 asterisks and 9 plus signs and 2 asterisks again. I was just wondering how we're supposed to get it to print that 6 times or 9 times or 2 times now. So that is the part that messed me up because I was just confused.
So right. So the amount of times that it prints is denoted by the for loop, and the symbol itself is chosen by the if statement. So it's when it's 6 or 2, it's even. So we say in the case where it's even, you're printing an asterisk. When it's odd, you print a plus sign. Okay? But the amount of times that you do print, right, is governed by the value of the value of the variable that you entered. So that's n. So we go for I is equal to 1 to n and say that we have that step 1 to iterate and go up. Every time that for loop goes up, it goes up by 1. Right? Remember, even in this whole structure, for any one iteration, only one of these print statements will be asserted. Okay? So in the case here where we've agreed, let's go with Eddie's solution. When we input n and we say, okay, n is 9, we work out when we divide 9 by 2, do we not get a remainder or do we get a remainder? We get a remainder. So that this first if condition is true. So we now go in and we say, okay, he is changing the value of n from 9 down to 0. Okay? So once he has, okay, is 9 equal to 0? Yes. Is 8 equal to 0? Yes. Is 7 equal to 0? Yes. For every yes that you get, print a plus and take away one value from n. Whereas mine uses the loop, and the value inside of the loop, the I here, goes from 1 to n. So we know that we will loop around n amount of times, and the value of n never changed. So each time it says stay constant with the plus. If it is that n was an odd number, or stay constant with the asterisk if n was an even number. Understood?
Yeah, I understand now.
All right, Jada. Understood? You comfortable?
So you broke up while you were saying my name, so all I know is that you said my name.
Yeah, I know. I realized I got kicked off. I asked if you were comfortable with the explanation.
Just this second question, I just still kind of, because, okay, is it going to print it like the plus sign? Let's just say it's 9, right? Is it actually going to print the plus sign 9 times, or just going to put 1 plus sign?
It will print it 9 times because it goes into the for loop 9 times.
Okay.
Because with the for loop, we have I initially starting at 1. So it'll check what n is, which is 9, a plus. And then I will be 2, it'll check, and it'll continue doing that until, of course, the value of I surpasses 9. The value of I will surpass 9, and it will and we will then stop the iteration of the for loop.
Okay, I see it. Don't worry, I see it.
Okay, good. All right. Any more questions or discussion before we leave? All right. So I just want to say thanks, guys, for coming. All right. I applaud you for taking the time and making sure that you're attending all of these sessions. Okay. It's really and truly on your part and my part to sacrifice to make sure that people are good, right? If you know somebody who's supposed to be here, encourage them to be here because this is an investment you're making for the long run. This is these are the fundamentals of all of the programming that is going to come. And the programming, it kind of gets complex. So the more fundamentals that you can get in, the better. So I know that the sessions recorded and people probably watch the videos, etc. But I really and truly encourage you to say, hey, you're doing computer science, come, because you could come. I encouraging people to talk. We could ask questions. We could discuss. You can't ask a video questions. You kind of just had to hope somebody asks a question that you're thinking about when you're watching the video afterwards. Okay. So that being said, that's it for us today. So I will see you all next week, Monday. And if it is that you all have any issues, you could use the Google Classroom and ask a question, or for those of you all who have my WhatsApp, you all could WhatsApp me. Bye-bye.
Okay, so thank you very much for class today.
Bye-bye.
Good day, everyone.
Yeah, bye, sir. Enjoy the rest of your night.
Thanks.